and welcome to Science of the Severn River series. In this session, we're going to be discussing Round Bay. I'm Diana Muller, and with us today we have Dr. Andrew Muller from the United States Naval Academy. We're both estuarine scientists, and we have been working with the Severn Riverkeeper organization as part of their chief scientists for the past few years now. Experts for the past 30 years, and we work closely with the Severn Riverkeeper organization. Weekly from July to October, us and a group of their volunteers and their staff go out and perform vertical water quality measurements in the tidal estuary using a YSI Pro multimeter for dissolved oxygen, pH, and temperature, as well as salinity. Dr. Andrew Muller and myself train these volunteers in accordance to strict QA/QC guidelines as per EPA Chesapeake Bay methodology, and we are part of the Maryland Tributary Assessment Coalition. The statistical analysis performed by Dr. Muller and myself using traditional protocols, and for mapping, we like to use ArcGIS Pro, Landsat data, and Google Earth Pro. So where in the heck is the Severn River? The Severn River is located in the state of Maryland on the western shore within Anne Arundel County. And today we're going to talk about Round Bay. So up here in the far right corner is a picture of Round Bay that we're going to be looking at. It's very unique. Here's a bathymetry chart of Round Bay. The average depth is about 22 feet and the circumference is about 3.25 miles. So if you look at the uniqueness of the bathymetry here, we do have a few shoals. We have Little Round Bay, the main section of Round Bay, and a small little island. And the geology.
Let's take a look at the geology of Round Bay and compare it to the South River, because that's really interesting differences between the two, leading to the uniqueness of Round Bay. On the right, we see the South River. These are the formation here is made up of basically marine sand, so low-lying relief, easily erodible, so it gives you the actual shape of the South River. Again, very erodible sands. On the other hand, let's take a look at Round Bay. On the southwestern side, you have the Magathy Formation, you have white sands, interbedded sands, you have some quartzose, a little bit more resistant pebbly material and quartzose material. On the northeastern side, you have the Mammoth Formation, which is, again, more clay material. And this is super important because that means in the Round Bay quadrangle section, you have some erodible sediments and some less erodible sediments. This actually leads to the round shape of Round Bay, and that round shape is very important because it's going to lead to stagnant water and the development of hypoxia and anoxia. Now we'll take a look at the circulation of the Severn River with some focus on Round Bay itself. And the physical oceanography is really important, the circulation, to understanding the dynamics and eventually the health and the living structure of the Severn River. We actually describe or classify the Severn River as a weakly stratified estuary. This means that we have fresh water coming in from over here on the left-hand side, so to speak, on this diagram. We've got fresh water coming in, leaving the estuary out on the top, and that means that salt water has to come in at the bottom. And that leads to a vertical density profile, so we have density changes both vertically and horizontally. And again, this is super important because when we get to Round Bay and it opens up, the area becomes even more stratified, leading to that hypoxia. So circulation is critically important. This is a diagram of salinity. This was taken recently in Round Bay from a couple of different sites. And what I want you to focus on is near the surface, we have pretty well mixed salinity. So close to the surface, it's fairly well mixed. And then as we start going down in depth, you can see that the salinity starts to increase pretty rapidly. And this is classic for Round Bay and for this weakly stratified type estuary. In fact, we use these salinity profiles to infer the circulation from the previous diagram because it's often difficult to get current meter data. So we use salinity as a proxy. So what we're seeing here is the salinity rapidly changing as we go down its depth, especially once we get beyond 3 meters. Keep in mind that 3 meters is going to be very important.
So now that we have talked about salinity, and in Round Bay, we have higher salinity at the bottom, which makes that water section more dense than its surface waters, which is what Dr. Muller meant about slightly stratified. So how does that affect the dissolved oxygen patterns? That has a tremendous effect on dissolved oxygen. So first, let's talk about the definitions of dissolved oxygen. Healthy is anything that's 5 milligrams per liter and above. Hypoxic is anything that's less than 5 milligrams per liter. Severely hypoxic is less than 2. And our dead zone is considered anoxic, and that's less than 0.2 milligrams per liter. And our diagram off to the right shows how you can actually obtain low dissolved oxygen levels, which is a very complicated diagram. So we have runoff, polluted runoff for the landscape. It can be either from a home or industrial, just human runoff. We have sewage runoff. It could be runoff from farms. It really doesn't matter. It's nitrogen and phosphorus running into our estuaries. The phytoplankton feed on that. They love that. They're like little Pac-Man gobbling all those up. And then they grow into these tremendous phytoplankton bloom creatures. And with that, they eventually utilize up all the oxygen. In the lower waters, where it's more dense, they utilize that oxygen, but then there's no circulation. There's no wind circulation. There's no circulation at all. It becomes hypoxic. And eventually over time, as we see in the case shortly in Round Bay, it becomes anoxic. And we have seen cases, we have brought up water samples where it actually smells like hydrogen sulfide. That is the true production of anoxia, where you go from oxygenated to bacterial remediation, where it is producing hydrogen sulfide.
Again, dissolved oxygen is important for our living resources, things that we're interested in like crabs and oysters and rockfish. And so you need a healthy oxygen for those living resources, including bay grasses. One unique way to study the dissolved oxygen in Round Bay is to use autonomous vehicles. And Diana and I have been able to do this over the last several years. And one way is to use what's called a REMUS, a Remote Environmental Monitoring Unit. And again, this is an autonomous vehicle, and we actually flew this in Round Bay in 2010. And we'll be able to show you the results of this because it gives you a nice three-dimensional view of dissolved oxygen. Okay, so taking a look at the map on the left, you can see the sort of where Round Bay is in relation to the entire Severn River and Chesapeake Bay, and the South River is below it. And the map to the right is actually the Remus Run in Round Bay. We did a zigzag pattern, and it actually went up and down in this zigzag pattern so that we can get the best coverage over the shortest amount of time. So we ran from the upper part of Round Bay all the way to about the mouth of College Creek. And here's the beginning of our runs. Here's temperature. In the middle where you see the wiggly line, so to speak, inside, that's actually the Remus position over as we went through Round Bay. Of course, this is sort of a model of Round Bay based on this data, so we make this into a nice little sort of rectangular model here. And now we're taking a look at temperature. Notice how hot it is at the surface. It's actually pretty hot throughout the entire water column. Really, really important for the dissolved oxygen. Here's the dissolved oxygen. This is the most troubling. You can take a look at this. We don't have to go that far down into Round Bay. We're getting around 3 meters or just below. We're starting to get very hypoxic in this 8-meter water column. Oftentimes, we've got extremely low dissolved oxygen coming up nearly halfway up the water column itself. Again, this is in August of 2010, but this is pretty common for much of the summer in the Severn River. Now, taking a look at dissolved oxygen more recently, we were out in 2020, And here are some vertical profiles for different sites. And the sad thing is that despite a decade's worth of trying to do stuff here in the Severn River, we still see the same issues, that once we get to about 3 meters, dissolved oxygen starts to crash pretty rapidly, and then we still have dead zones. And so it's really important to continue working on our restoration efforts, but recognizing that this is going to take a long time to fix the problem.
So here's a different type of map of Round Bay. And again, our definitions off to the side. Where healthy is 5 and above, hypoxic is 5 and below, severely hypoxic is below 2. And then we have our dead zone. So Round Bay, for most of the summer, is not a good hospitable place for organisms. Striped bass prefer it between 5 and 6 milligrams per liter, yellow perch 5, blue crabs cannot have it below 3. Spot, nothing below 2. Worms, which might be gross to some people, they're highly necessary as a huge part of the food web. Anything below that can't live. So when we talk about Round Bay's dead zone, what we really need to talk about is what Dr. Muller and I have termed hypoxic squeezing. And that actually relates to the livable habitat of the organisms that have to live in the water. Humans, we can get out of the way if it gets too hot. We can go into air conditioning. But what about our poor fish? What about the blue crabs? What about the other species that have to live in these conditions? What happens during the summer is we get really, really hot. And then on top of it, we couple that with hot rain, those hot July rains beating on all of the impervious surface, all of the concrete and all of the asphalt runs right into the Severn River, and it drains into Round Bay. And now we have hot, a little bit fresher water sitting on warm, salty water. It reduces the circulation, and that warm bottom water, the dissolved oxygen, that hypoxic layer becomes anoxic, and the livable area actually squeezes. And it squeezes to a point where we have seen hypoxic conditions literally 2 feet below the surface of Round Bay. So while everybody is boating around and recreating and having a lot of fun, what they don't realize, dissolved oxygen is invisible. You can't see it, you can't smell it, unless the bottom waters turn into rotten egg smell, hydrogen sulfide. But the poor critters, as we see in this graphic here, can't live. This bathymetry chart is overlaid with a heat map. And what this tells us is the hottest sections within the Round Bay sector. So during the summer, not only do we have hot temperatures, but we have nutrient-laden nitrogen and phosphorus and hot water. Then when it rains during our summers, we have hot, nutrient-laden, along with other particulates such as metals and pharmaceuticals going into our waterways. And that sets up a positive feedback loop. Hot, nutrient-laden water. And phytoplankton love that. And they feed on that like little Pac-Men. Then we have these large algae blooms. These large algae blooms eventually die. That dead matter decomposes and goes to the bottom waters. Our anoxic bottom waters starts rising to the top, further and further up the water column, creating an even worse problem. So important to note the really healthy aspects of Round Bay, even though we have a dead zone in the center of Round Bay that does need to be restored. We have beautiful underwater grasses all around the edges in the shallow section of Round Bay. In most of the rest of the section of the Severn River, we do not see this, but we see beautiful redhead, sago pond, and widgeon grass. These areas are the perfect habitat for our juvenile fishes, our blue crabs, to breed and grow. They also provide oxygen into the water column, which is highly important for the entire ecosystem. So Round Bay is a diverse, unique section of the Severn River. It's bowl-shaped, contains the dead zone, the anoxic waters, and through restoration, that section can be fixed by reducing nitrogen and thermal pollutants, and it will increase the fisheries habitat, and maybe toward the center, we would be able to get a diverse species of our fisheries. The underwater grasses would be able to expand and grow throughout the rest of the section of the Severn River. This is a general graphic, estuarine processes, and what climate change is doing to Round Bay area. So we have residential runoff, we have septics, we have hot water, we have a lot of precipitation. This past August, we ended up with a ton of rain, and all that rain carried with it all of the runoff. And that runoff has nitrogen, phosphorus, and other contaminants in it that we'll get into in another series that enhances algae blooms. And these algae blooms eventually lead to our dead zone. This is one of the Science of the Severn River Watershed series. The Severn Riverkeeper believes in restoration, authentic science, and extreme advocacy. Fred Kelly and Sarah Caldas are great Severn Riverkeepers and executive directors. And if you guys have any questions, please contact us at severnriverkeeper.org. Go to our Facebook page, the Severn Riverkeeper Program, and subscribe and like us on YouTube. And again, this is Diana and Professor Muller. Thank you guys very much.